welcome to The Explainer. I am absolutely thrilled to have you here today. Look, if you're focused on building resilient, scalable, and highly secure software systems, you are in exactly the right place. Today, we're setting the stage for a really fascinating architectural journey. We're going to explore a strictly decoupled DevOps architecture. We'll be looking at how we can completely snap our continuous integration and continuous deployment in half using powerhouses like Jenkins, Harbor, ArgoCD, and Kubernetes. And specifically, we're going to look at how we seamlessly bridge a Docker Swarm environment with a Kubernetes cluster. So let's get right into it. So what actually happens when you snap your deployment pipeline entirely in half? For years, the industry standard has kind of been this tangled, monolithic CI/CD pipeline. You definitely know the one, a single script or automation server that pulls the code, builds the container, runs the tests, and then directly pushes it straight into the production cluster. But that traditional approach, it brings some massive inherent pain points. We're talking terrifying configuration drift, huge security risks where your build server literally holds the keys to your production kingdom, and just overall scalability nightmares. What if we just broke it right down the middle? Okay, let's dive into Section 1, the Great CI/CD Decoupling. To really wrap our heads around this, let's use a restaurant analogy. On the left side, we have continuous integration. Think of this as the kitchen, and in our specific infrastructure, this kitchen runs entirely on a Docker Swarm. The developers are our chefs writing and committing code. The CI system prepares the food, basically cooking up a finalized Docker image. Now, over on the right side, continuous deployment is the waiter, operating entirely over in our Kubernetes cluster. The waiter's only job is to look at the order ticket, pick up the prepared food, and set the table for the customer. The absolute golden rule of this entire architecture is this: the chefs never serve the food, and the waiters never cook it. They emphatically never cross paths. Moving right along to Section 2, CI Code to Artifact Registry. Let's start by exploring that kitchen where raw code actually transforms into a stored artifact. This workflow is a strict linear progression. Step 1, a developer commits code to a Git repository. For us, that's specifically our Gitia instance over at gogs.starsellersworld.com. That action triggers a webhook. Step 2, Jenkins, which is hosted at jenkins.starsellersworld.com, catches that webhook and springs into action. It uses a declarative pipeline defined in a Jenkins file to build the application and package it up into a Docker image. Step 3, Jenkins takes that freshly minted image and pushes it securely to our Harbor registry at harbor.starsellersworld.com. Now, I want to emphatically state what happens next. Absolutely nothing. Jenkins builds and Jenkins pushes, and then it's done. I seriously cannot stress this enough. Jenkins builds the Docker image, but it does not deploy. We are enforcing a strict, non-negotiable isolation constraint here. Jenkins acts merely as our CI automation server. It processes code through its multi-branch pipeline, runs our tests, packages the artifact, and then it stops. It holds 0 credentials for our production Kubernetes clusters. It has absolutely no access to the deployment environment. So where does that image actually go? Well, Harbor is the artifact registry that securely stores it. Harbor is an awesome open-source CNCF graduated registry that runs on our Kubernetes cluster. Going back to our restaurant analogy, Harbor is the pantry, or maybe the warming rack. It secures our artifacts with robust policies, role-based access control, and built-in vulnerability scanning. Those built Docker images just sit there securely, waiting for the next phase. All right, let's look at Section 3, CD, the GitOps pull model. We are officially leaving the kitchen and entering the dining room. This quote, pulled directly from the ArgoCD documentation, firmly anchors our CD philosophy. It says ArgoCD follows the GitOps pattern of using Git repositories as the source of truth for defining the desired application state. This is a massive fundamental shift. We aren't actively pushing changes into our cluster anymore. Instead, we're simply updating a manifest file in a Git repository, specifically the Kubernetes applications repo back in our Gitia instance. We're just declaring to our ArgoCD instance located at swapi.starsellersworld.com/ArgoCD, hey, this is what the world should look like now. Now, to make GitOps actually work, we really need to understand a vital concept: out of sync. ArgoCD is implemented as a Kubernetes controller that continuously monitors your running applications. It's constantly comparing the current live state of your cluster against that desired target state written in your Git repository. So if somebody changes the manifest in Git to say we need version 2.0 of an app, but the cluster is currently running version 1.0, ArgoCD instantly flags that application state as out of sync. So here is the crucial point to remember. ArgoCD reconciles the cluster state. When it detects that out-of-sync drift, the ArgoCD application controller actively pulls the new manifests from the Git repository and applies them to the Kubernetes cluster to correct that drift. It's the waiters setting the Kubernetes table. But remember our golden rule. ArgoCD deploys, but it never, ever builds. It literally doesn't know how to compile code or package a Docker container. It never does the kitchen's job.
Which brings us nicely to Section 4, the invisible deployment handshake.
Think about this for a second. We have CI completely isolated on one side and CD completely isolated on the other. It's a genuine puzzle, right? If Jenkins and ArgoCD never actually talk to each other, how does the application deploy? Think about our constraints. Jenkins pushes an image to Harbor and stops. ArgoCD syncs a text manifest from Git to Kubernetes and stops. Harbor and ArgoCD do not interact directly, and Jenkins certainly never commits back to the Git deployment repository. They are totally blind to one another. Well, here is the big aha moment. The bridge between these two worlds isn't some complex pipeline script, it's the infrastructure itself. Here is the exact sequence of events. First, your Git repository holds the updated manifest pointing to the new image tag. Second, ArgoCD syncs that manifest to Kubernetes, basically telling the cluster, hey, you should be running this new image. Third, and absolutely most importantly, the Kubernetes cluster itself, using its Container Runtime Interface, or CRI, independently reaches out and pulls that new image directly from Harbor.
Let's really hammer home this critical architectural constraint one more time. Harbor and ArgoCD do not interact. The Docker Swarm environment, where Jenkins and Gitia live, never touches the Kubernetes environment. Jenkins never commits back to Git. The invisible handshake relies entirely on that final autonomous pull from the Kubernetes cluster. ArgoCD simply updates the instructions and Kubernetes autonomously fulfills them by fetching the artifact from Harbor. It is just a beautifully decoupled ballet.
Wrapping up with Section 5, why strict isolation wins. So why go through all this effort to set up such strict isolation? Let's summarize the core benefits drawn directly from this architecture. First up, security. This is massive. If your Jenkins server is ever compromised, the blast radius is totally contained. It doesn't hold your Kubernetes cluster credentials, meaning CI cannot breach production. Second, scalability. Because they don't depend on each other, you can scale your Jenkins CI swarm entirely independently from your ArgoCD Kubernetes controllers. And finally, auditability. Every single deployment change is a Git commit. Your audit trail isn't buried deep in some obscure CI log. It's explicitly version controlled right there in Git, making disaster recovery and rollback as simple as reverting a commit. We have covered a lot of ground today, moving from the risks of the monolithic pipeline to the elegant security of a strictly decoupled CI and CD workflow. By intentionally isolating Jenkins and Harbor from ArgoCD and Kubernetes, we rely on the invisible handshake of the cluster to bring the whole shebang together. So, I'm going to leave you with this final thought. Are you ready to abandon the monolith, restructure your deployment pipelines, and fully embrace the decoupled GitOps journey? Thank you so much for joining me on the Explainer today, and keep learning.